Lesson 39, Confidence Interval Estimation for the Difference in Two Population Proportions. Example 2. A Harris Interactive poll asked a random sample of adults, "Do you think that participating in an internet romance is cheating on your partner?" As a result, 86.9% of 283 men polled and 97.5% of 317 women polled thought that participating in an internet romance was cheating on their partner. Use a 95% confidence interval to estimate how much less likely men are than women to think that participating in an internet romance is cheating on their partner. So in this example, we want to use a 95% confidence interval. So we'll be constructing a confidence interval using the customary 95% or 0.95 confidence level to estimate how much less likely. Now, likely or likelihood is a probability, and probabilities take on the form of proportions. So here we're estimating a proportion that men, which is one population, are than women, a second population. So this is estimating the difference between two population proportions, P1 and P2. This can be expressed symbolically as L is less than P1 minus P2 less than U, where P1 is the proportion for the first population, which is men, and P2 is the proportion from the second population, which is women. So 1 is designated the men as our first population, and 2 is designating women as our second population. So we'll be conducting a confidence interval to estimate the difference between two population proportions. To do this, we use the following to guide us through the process of constructing our confidence interval estimate. Starting with selecting 1 minus alpha, the confidence level. We'll be using our customary 0.95. Next, 2propzient is the command on the TI-84 calculator that we use to construct our confidence interval. But to do this, we need to enter the data into the calculator. So when we're told that 86.9% of 283 men polled, the 283 men being our first sample would be N1 equals 283. Had a 86.9% who thought that participating in an internet romance was cheating on their partner, this would be our first sample proportion, P1 hat, which equals 0.869 decimal. Now the required input on the TI-84 calculator is the X1 and N1. So we need to solve for the X1 based off of the sample size and the sample proportion. To do this, the X is equal to the N times the P. In this case, the 283 times the 0.869, which equals 245.927. But recall the data value X is discrete because it's a count or frequency, and so it needs to be a whole number only. So the X1 is rounded to 246. So we have our first sample results. In the second sample, 97.5% of 317 women polled thought that participating in an internet romance was cheating on their partner. So the 317 women polled is our second sample size. So N2 equals 317. And the 97.5% is our second sample proportion, or P2 hat. P2 hat equals 0.975 decimal. Now the required input on the TI-84 calculator is for the actual data value, X2, and the sample size, N2. So when we're given N2, the sample size, and P2 hat, the sample proportion, we could solve for X2 by multiplying the values, N2 times P2 hat. In this case, X2 equals 317 times 0.975 equals 309.075. Again, X2 is the data value, which is a count, which is discrete and must be a whole number only. So we round off this result, X2, to 309. So now that we have our data values, we can use these data values in the TI-84 calculator's 2propzient command to construct our confidence interval estimate. So on the TI-84 calculator, we would press Stat to do statistics, arrow over to Tests, the menu where we do all our confidence interval and hypothesis test commands, arrow down until the cursor is next to 2prop_z_int. We select Enter, and then we enter in the data values. x1 equals 246, enter. n1 equals 283, enter. x2 equals 309, enter. n2 equals 317, enter. We're using the customary 0.95 level of confidence. Arrow down to calculate and press enter. Under the 2prop_z_int command, in parentheses, separated by commas, is our confidence interval estimate from L, the lower limit, to U, the upper limit. Proportions are probabilities, so we just need to round these off to 3 places after the decimal. So the estimate would be negative 0.148 less than P1 minus P2 less than negative 0.063. So now that we have our confidence interval expressed symbolically, we can now express our confidence interval verbally. With 95% confidence, the difference in the percentage of men and the percentage of women who think that participating in an internet romance is cheating on their partner is estimated to be between negative 14.8% and negative 6.3%. Here, since both values of L and U are negative, this indicates that the first population proportion is less than the second population proportion. The first population was of men, so we can reach this conclusion. Therefore, it is estimated that men are anywhere from 6.3% to 14.8% less likely than women to think that participating in an internet romance is cheating on their partner.